Double I, the point on AB such that OP is perpendicular to AB. Okay, now what's happening here? So that is saying you have point P somewhere. It doesn't have to be in the middle. It can probably be, you know, maybe here or somewhere, such that O to P is perpendicular to A to B, right? So O to P is perpendicular, that means 90 degrees to A to B. The first thing you want to do here is find vector OP first. Find, like, you know, it's like what can OP be? As we mentioned before, OP is OA plus OA plus AP. But unlike last time where AP was half of AB, right here, this time it's not halfway. We don't know, right? So you can only say that OP is OA plus some scalar multiple. We'll call that lambda of AB. So that's all we can say. It's not halfway, right? So let's add that up first. OA in this case is 3i plus 4k. And then plus lambda of AB. Well, we know AB is just this one right here, negative 2i plus 2j minus 6k. So I'll write that down, minus 2i plus 2j minus 6k. And then let's add that up. We get 3i plus 4k minus 2 lambda of I. And then plus 2 lambda of j. And then minus 6 lambda of k, and then we group them together. So 3 minus 2 lambda, that is I, and then plus 2 lambda of j, because there's only one j here, and then plus 4 minus 6 lambda of k. So 4 minus 6 lambda of k. So we're just grouping the coefficients together for each of the respective unit vectors. OP equals to that. We're going to use this a lot, so make sure we, I guess, note that down. This part right here, so star that. Okay, cool. So we now know OP is, you know, something like in this form with the lambda. We only have one variable, which is good. We now want to find that variable, right? What do we know? What did the question say? The point AB such that OP is perpendicular to AB, right? So that is saying that if I was to dot product OP and AB together, then if they are perpendicular, we have this rule with vectors, they are equals to 0. So in that case, we are going to dot product and then solve for lambda. Once you solve for lambda, you can find what OP is. And let's write that down. I'll do this quickly, speed up the video a little bit. 2i minus 2 lambda plus 2 lambda times by j plus 4 minus 6 lambda times by vector k. Of course, this whole thing right here, if you were to dot product with AB, and what do we know what AB is? Well, AB, we found that previously, just right here, that's what AB is. This one, that's AB. Well, that is negative 2i plus 2j minus 6k, and that should equal to 0. So let's multiply the coefficient together. 3 minus 2 lambda times by negative 2, that is negative. So let's multiply, expand the bracket, negative 6 plus 4. 0. Okay, now 4 lambda plus 4 lambda plus 36 lambda, that is 44 lambda. And then we move the 24 and the negative 6 over to the other side, we get 30. So therefore, lambda is 30 divided by 44. We can simplify that by 2 and we get 15 over 22. Right, so now let's solve for what OP is. Just chuck it back inside your vector. So 3 minus 2 times lambda, we already know what lambda is, and that's it. Just try to solve for it, right? So let's go. 3 minus 2 times 15 on 22. The 2 simplifies with the 22 and you get 3 minus 15 on 11, and that's the I component. Plus 2 multiplied by 15 on 22, well, that's just 15 on 11j. Okay, so I'm just chucking lambda inside your what we had originally with the lambda, okay? 4 minus 6 times lambda, 6 of course, times can simplify, so 6 multiplied by 15 on 22. Let's see what that simplifies to. Well, this one becomes 11, that becomes a 3, so that's 45 on 11, and then k. Right, now let's just add up the fractions, or minus the fractions. 3 minus 15, that would be 33 minus 15, so that's 18 on 11i, and then plus 15 on 11j. And then of course this would be 44, so that's minus 1 on 11k. And there we go. So that is your vector OP, okay? So to answer this question, it really was about, your dot product. If you were to dot product OP and AB, you get 0, and you also had to make a vector OP by yourself. This time it wasn't halfway. That's why we use lambda instead, right? So lambda over here, which is lambda of AB. We know P is somewhere on AB, so it's OA plus lambda of somewhere of AB. That's it, okay? So that was double I. Let's move on to triple I. Okay, I'll write it here on the side so that we don't use too much space. Right, so let's read the question for triple I. The point where the bisector of AOB is intersects AB. Okay, so we're finding the vector OP where point P is the point where the bisector. So that means the point P, when you draw O to P, it cuts your angle, it cuts your AOB, the theta that you found previously, into two equally spaced angles, okay? So those two angles, it cuts them, it bisects them, right? So what does that mean? Well, let's write down mathematically what that means first. Angle AOP is equals to angle POB because they bisect, right? OP bisects these the AOB. So AOP, that angle right here, I'll call it the first one, is equals to POB. That's the second one because it got bisected. Okay, now of course, if you, once again, it's coming back to the angles. If you want to find what angle AOP is, well, cos theta equals, all of that. But essentially that's saying cos of AOP is equals to cos of angle POB. And we know the formula for cos of this is the dot product once again. So the dot product is OA and OP. So that's for this angle right here. So I'll write that down. It is the dot product of the vectors OA and OP divided by the magnitude of OA multiplied by the magnitude of OP, right? So if you were to do this, you'll be able to find cos of the angle. And of course, they are the same, so you might as well just ignore that. Write them down in this form first. Same thing with POB. So POB, that is the dot product of vector OP and OB. So OP multiplied by OB divided by the magnitude of OP multiplied by the magnitude of OB. And what we can see here is that they cancel each other out, the magnitude wise. You can't cancel out the vectors. Once you dot product vectors, you can't cancel them out. But the magnitude is just a constant. You can definitely cancel out constant. OP is the same as OP. Get that out of your equation, right? So now you only have this. So it's all about filling in your vectors now. So what is vector OA? Well, vector OA, we know up here on the diagram is 3i plus 4k. So let's write that down, 3i plus 4k. And then what is vector OP? Well, vector OP, as we found here, is this form right here with the lambda. So once again, P is not halfway. We don't know that. We just put it in terms of lambda. We don't know that lambda is this much. That's only when lambda is 15 or 22, then it doesn't bisect, it just cuts 90 degrees. This one is a different type question, but we can still use what we did in double I to help us. So 3 minus 2 lambda times by vector I, and then plus 2 lambda times vector j, and then plus 4 minus 6 lambda times vector k, right? So that is OP, and then of course we divide by the magnitude of OA, which we know is 5, right? So square root of 3 squared plus 4 squared. Same thing here, move it on over to the right hand side. OP is pretty much the same thing, what we have here. And I think for some reason the ink is fading, even though this is digital, so that's a bit weird. Multiply by vector OB. Well, what do we know about vector OB? That is I plus 2j minus 2k. So I plus 2j plus 2k, just to make sure that was plus. No, that was minus 2k. Is minus 2k. And of course, everything is divided by the magnitude of vector OB. Magnitude of vector OB, well, in this case, we know is you just square root that, and then you square the coefficient, and we get 3, right? So now it's all about solving for lambda once again. So let's multiply them out and see what we get. 3 times by this is we get, so 3 multiply, only the I coefficients, okay? So 3 multiplied by 3, that's 9. 3 multiplied by negative 2 lambda, that's negative 6 lambda. This is going to be quite long, so I'll speed up the video and you end up with the results, hopefully. And then everything is over 3. Let's simplify everything here. So that's 9 plus 16, that's 25 minus 30 over 30 lambda, everything is over 5, equals to 3 minus 8, so that's minus 5, plus 4 lambda, 12 lambda, so that's 16 lambda, minus, so plus 14 lambda, everything over 3. And then of course the lambda here, the 5 here cancels out nicely, and you get 5 minus 6 lambda. You can't cancel anything here, so we'll leave that there as 3. And then move the 3 over, you get 15 minus 18 lambda, and you get negative 5 plus 14 lambda. So let's solve for the lambdas. Move the negative 18 to the other side, we get 32 lambda, 18 plus 14. Move the 5 to the other side, it's now 20, and therefore lambda is 20 divided by 32. Divide them by 4 and you get 5 on 8. So that's what lambda is, and there we go. If you want to solve for OP, what do we know about OP? Once again, OP is this form right here, this vectors right here. 3 minus 2 times lambda. 2 times this is 5 on 4. I. And then we have plus 2 times lambda. So 5 over 8 times by 2. That is 5 over 4j. And then we have this one right here, 4 minus 6 lambda. So plus 4 minus 6 times this. So 6 we'll do on the side. 6 times 5 on 8. That is 30 on 8. Divide both sides by 2 and you get 15 on 4. And there we go. So it's 4 minus 15 on 4k. And let's do the maths. 3 minus 5 on 4, that is 12 on 4 minus 5 on 4. So that is 7 on 4i plus 5 on 4j. And then of course it's 16 minus 15. So that is plus 1 on 4k. Right, so that is your answer for OP. So this form, right, OP right here, is when your OP bisects AOB, okay? So that's pretty much it for question 7, chapter 2e. This is the last question of that chapter, of this topic. It is quite long, but hopefully you found this video useful. Aside from that, guys, thank you for watching, and I'll see you in the next video.